Welcome to this explainer. Today, we're getting an exclusive look inside the Cambridge AS and A-level computer science syllabus, specifically for course 9618. If you've ever found yourself wondering what the people grading your papers are actually thinking, well, you are in the perfect place. We're going to unlock the exact frameworks examiners use to grade you. We'll be focusing on a topic that literally trips up thousands of students every single year, the impact of sampling rate and resolution on file size and accuracy. So let's dive right in and decode the examiner's playbook together. Here's our masterclass roadmap for today. First, the examiner's secret. Second, core principles. Third, technical methodology. Fourth, top 3 mistakes. And finally, deconstruct, solve, evaluate. Section 1, the examiner's secret. Listen to this direct quote from a senior Cambridge examiner. They noted that the difference between a B and an A star often comes down entirely to how well you understand the impact of sampling rate and resolution on file size and accuracy. Let that sink in. This isn't just some minor subtopic to skim over. It's a fundamental pillar of the syllabus. It's the main battleground where those top grades are won or lost. Mastering this proves to the examiner that you truly grasp the real-world physical constraints of digital computing. According to principal examiner reports, there are 3 highly challenging core concepts embedded in this topic that candidates just constantly stumble over. We're going to conquer every single one of them right now, making sure you don't fall into the same traps that keep so many students stuck at a B grade. Section 2, core theoretical principles. Let's clear this up right now, because students frequently find it incredibly difficult to distinguish between these 2 very similar concepts, sampling rate and resolution. You absolutely must establish precise definitions here. So, think of sampling rate as being about frequency, how often you're taking a snapshot of continuous data, like an audio wave. Resolution, on the flip side, is about the detail. It's how many bits you're actually allocating to represent each one of those individual snapshots. The examiner is looking for you to explicitly define these and then map out their direct causal relationship. Basically, if you increase the rate or the resolution, you inevitably increase the accuracy. But the catch? You also bloat the file size. Nailing that precise trade-off is absolutely crucial. Top-performing students don't just spit out memorized facts. They operate within a broader conceptual framework. This requires systematic analysis, evidence-based reasoning, and, this is a big one, cross-topic connections. Principal examiner reports explicitly highlight that candidates who tie in cross-topic connections get significantly higher marks. For instance, when you talk about a file size increasing because of a higher sampling rate, how does that actually impact network transmission speeds or storage hardware limits? When you connect those dots, you prove to the examiner that you have a comprehensive mastery of computer science, rather than just knowing a bunch of isolated trivia. Section 3, technical methodology. When it comes to algorithmic thinking and data interpretation, examiners expect to see a very standardized sequence. Step 1, identify the key elements in your prompt. Step 2, apply the relevant principles of rate and resolution. Step 3, execute your analysis and show clear, visible working. Step 4, verify your results. Ask yourself, does this actually make logical sense? And Step 5, present your findings in the correct format. Whether you're extracting file sizes from binary or evaluating a compression algorithm, strictly following these 5 steps ensures you hit every single assessment objective on their grading rubric. Okay, pay attention to this official examiner alert, taken straight from the reports. Show you're working. Data interpretation and algorithmic calculations are so critical here. Look, even if your final calculated file size is completely wrong, maybe you just made a goofy arithmetic error when converting bits to megabytes, you can still save your grade. Using what examiners call the method mark strategy by showing your step-by-step calculations guarantees you pick up points. An A-star student knows the process is just as valuable as the final answer. Never, ever leave the examiner guessing how you got to your conclusion. Section 4, avoiding top 3 mistakes. All right, here they are, the 3 absolute biggest grade killers. First up, confusing cause and effect. Students constantly mix up whether a larger file size forces a higher resolution or if a higher resolution causes the larger file size. Just to be clear, it's the latter. Second, forgetting boundary conditions and edge cases. When you're designing an algorithmic solution to calculate a file size, what happens if the sampling rate is exactly 0? What if the resolution exceeds standard system limits? You always have to test your logic against the boundaries. And third, providing answers that lack specific context. Examiners note that students love to just repeat memorized definitions. Don't do that. Tailor your answer to the actual scenario in the question, whether it's streaming a live concert or storing a high-res medical scan. Context is everything. Section 5, deconstruct, Solve, evaluate. This deconstruct, solve, evaluate framework is exactly what top-scoring candidates use to analyze trade-offs and build airtight decisions. Imagine you're faced with a really complex problem about optimizing a file for both accuracy and size. First, you deconstruct it by identifying the constraints. Next, you solve it systematically. And finally, and most importantly, you evaluate. Check for reasonableness and make justified recommendations. It is not enough to just say, lower the sampling rate. You have to justify exactly why that recommendation makes sense for the limitations of that specific scenario, and back it up with the evidence of your calculations. You can see how this naturally builds into the comparative analysis framework. When an examiner asks you to evaluate different sampling rates or resolutions, they're really testing your comparative analysis skills. Remember, true comparative analysis means identifying similarities and differences. You've got to use appropriate connectives, words like whereas, conversely, or similarly, and absolutely every claim must be backed by solid evidence from the data they gave you. If you can mentally build a table comparing these elements, you'll make sure your written answer covers all the bases for maximum marks. Now, we all know that under the intense pressure of an exam, it's super easy to freeze up. So here's a powerful memory hack. To ensure these core principles actually stick, create your own mnemonic using the first letters of the key terms: sampling rate, resolution, file size, and accuracy. Having a simple, catchy phrase ready to go in your head means you can instantly recall the technical frameworks and structural steps we've talked about today. It lets you bypass the panic and jump straight into systematic processing. We have covered a ton of ground today, all the way from the fundamental differences between rate and resolution to the strategic importance of method marks and comparative analysis. So I want to leave you with this final thought. As you review your own study habits and sit down to tackle your next past paper, ask yourself, will your solutions survive the edge cases? Are your answers truly contextualized and rigorously tested against the data provided? Because moving away from passive memorization and toward rigorous, evidence-based evaluation, that is your definitive path to mastery. Keep analyzing, keep testing, and apply these frameworks to every single problem you face. Good luck!